Let's do a complete example of a rational function. Let's do changing the color to black. F of x equal 4x minus 8 all over x to the second minus 3x minus 4. And let's find the x-intercepts. X-intercepts, if any. Let's find y-intercepts, if any. Let's find asymptotes. Let's find, let's graph. And finally, last part, let's identify the domain and range. So let's start with x-intercept. Let's go to the next page. I do have, we're starting with f of x equal 4x minus 8 over x to the second minus 3x minus 4. The first question I'm going to ask myself is there a factor on the numerator that could cancel a factor in the denominator? In other words, is f of x in its most reduced form? Well, let's find out. Let's factor the numerator. That factors out to 4 times x minus 2 over the denominator factors to x minus 4, x plus 1. And nothing is canceling out, so f of x is on its most reduced form. So I'm ready to go. Part A, we were trying to find out the x-intercepts. So to find x-intercepts, let y equal 0. So I'm going to say 4 times x minus 2 over x minus 4 times x plus 1. Set that equal to 0. So we know it is sufficient for the numerator to equal 0. I'm going to set the numerator 4 times x minus 2 equals 0. Using zero product property, 4 equals 0 and x minus 2 equals 0. 4 equals 0 is nonsense, so I'm going to trash that. Adding 2 to both sides of this equation, I get x equal 2. So I do have an x-intercept at x equals 2. So x-intercept, I do have at 2, 0. Now, next, we're going to find what is the y-intercept. Going to the next page. Again, we're starting with f of x equal 4x minus 8 over x to the second minus 3x minus 4. And to find y-intercept, let x equal 0. So I'm going to have f of 0 equals 4 times 0 minus 8 over 0 to the second minus 3 times 0 minus 4. This gives me negative 8 over negative 4. It gave me a 2 again. So the y-intercept is also at 2. So y-intercept is at 0, 2. Okay. The next part, we were asked to find the asymptotes. So going to the next page, we know that f of x equal 4x minus 8 and x minus 4, x plus 1. So to find asymptotes, let's say we potentially a rational function can have horizontal asymptote, vertical asymptote, slant asymptote. Okay. So horizontal asymptote, let me just remember that the original f of x was 4x minus 8 over x to the second minus 3x minus 4. So notice that the degree of the top is smaller than the degree of the bottom. So the numerator has a lesser degree than the denominator. So as x is approaching infinity, f of x is approaching 0. So I conclude that y equals 0, that is the same as x axis, is the vertical asymptote. Oh, sorry, horizontal, I apologize, is the horizontal asymptote. Okay. How about vertical asymptote? We said that to find the vertical asymptote, set the denominator equals 0. Set denominator equals 0. Well, the factor formed of the denominator is x minus 4, x plus 1 equals 0. Using zero product property, x minus 4 equals 0, x plus 1 equals 0. That gives me x equals 4 and x equals negative 1. So I have two vertical asymptotes at x equals 4 and x equals 1, negative 1. So two vertical asymptotes. And this graph doesn't have a slant asymptote. Remember that we said to have slant asymptote, the degree of the numerator must be higher by 1 degree, and the degree of the numerator is not higher than the degree of the denominator. And we also know that as a general, as a rule of thumb, you cannot have horizontal and slant asymptote at the same time. Because if the degree of the top is higher to have by 1 to have slant asymptote, that would mean there is no horizontal asymptote, because horizontal asymptote does not exist when the degree of the numerator is higher. So once again, no slant asymptote, no slant asymptote. I didn't have to do any work for that. Okay. So now let's just go to the next page and graph this. So I'm going to draw the x-axis, which is my horizontal axis, right here. And then here's my y-axis. So x and y. So we said that we do have horizontal asymptote at y equals 0. So let me grab a blue color. So this is like, I'm going to try to put some dashes here just to remind myself that this is my horizontal asymptote. And we said that we have vertical asymptotes at x equals -1 and x equals 4. So 1, 2, 3, 4. Or maybe I just make my tick marks a little bit smaller. Actually, better than that, I could move the y-axis a little bit to the left, maybe in here. So let's have a -1, +1, 2, 3, and 4. And so I have a vertical asymptote here and here. And remember that we found out that the x-intercept was at +2, and the y-intercept also was at +2, somewhere here. So the middle part of the graph is actually easy for me because my graph must cross these 2 points. Something like, curve. This is like, I'm gonna make it curvy like this, and this have to approach my moving towards the vertical asymptotes. The graph gravitates toward the vertical asymptotes. And if you're not sure, just plug in more numbers, choose some numbers. Like, for example, you can plug in 3 and see what happens. And it gives you f of 3, and it's going to be somewhere down here. How about to the left of -1? So this one was -1. This point was 4. What's happening to the left of -1? Notice that we started at 4x minus 8 over x to the second minus 3x minus 4. If I go to the left of -1, let's say -2, so I'm going to have, let me do it here, f of -2 equals 4 times -2 minus 8 over -2 squared. Let me give myself a little bit room. Minus 3 times -2 minus 4. And that gives me -16 over +4 plus 6 minus 4. So I have -16 over 6, which is the same as saying -8/3. So -2 will result at -8/3, somewhere down below in here. And because my graph is gravitating towards the asymptotes, this graph must look like something like that, because it is going towards the asymptote. Remember that I do have the horizontal asymptote at x-axis, or y equals 0, and I have a vertical asymptote at -1. Once again, if you are not sure, you're more than welcome to plug in more numbers. Just make a t-table and convince yourself. How about to the right of 4? To the right of 4, let's pick a number. How about 5? If I plug in 5 in my original function, then I get 4 times 5 minus 8 over 5 to the second minus 3 times 5 minus 4. That gives me 20 minus so 12 on the numerator. Then I have 5 times 5 is 25, minus 15, minus 4 is minus 19. So I have 12 over 6, positive 6, which equals 2. So positive 5 goes to somewhere at 2. Okay. So notice that again, my graph has to gravitate towards the asymptotes. So the graph is going to look like this. This is going towards, from top and bottom, it's going to gravitate towards the asymptotes. Unfortunately, the screen that I have in my possession in my iPad is way too small for me to show you more details. So my hope is for you to grab a bigger piece of paper, or at least graph it on a TI-84 or Desmos and look at it for yourself. With the rational function, if you find the vertical asymptote, if any, and horizontal asymptotes, if any, and the slant asymptote, the rest of it is just plugging in a couple of numbers to convince yourself in what direction the graph is moving. So the last thing for this problem, we wanted to identify the domain and the range, the domain and the range. Let me go to the next page. So for the domain, I had all real numbers except -1 and +4. So I'm going to say x such that x cannot equal -1 and 4. This is one way of identifying the domain. The more common way is to say from -infinity, and -infinity is never in bracket. So all the way to -1, -1 is excluded, together with or union from -1 to 4. 4 is not included, together with from 4 to +infinity. So this was my domain. This is the domain. Well, let me put this domain x such that x cannot be -1 and it cannot be +4, or from -infinity to -1, together with -1 to 4, together with from 4 to 8. And how about the range? Let me just go back to our graph. Notice that the range or the y values, it goes all the way up, keeps going forever, and keeps going forever down. So the range is going to be range for this function is all real numbers. Oops. All real numbers. Or you could say from -infinity to +infinity, either way. So it depends on the textbook. So let me try this one more time. All real numbers, how about something like, I'm not being really good with this, sorry about that. Okay, well, why don't you just stick with this so you don't have to get involved with the shape of it. All right, we'll do more examples soon, and thanks.